Okay, so good evening, everyone. I'll start today's session. So this is actually the class for the last week, Saturday on 7th September. I could not take the class. So it is the compensation class for this. So I had to take on Tuesday today. From next week onwards, the classes will be at the regular timing. That is Saturday, 7 o'clock to 9 o'clock. Okay, so last week we were talking about regression, right? So any doubts, any questions about the last class? Any clarifications you need?
No, everything is okay.
No, sir. Everything is clear.
Oh, okay. Okay, so I'll start today's lecture then. I'll just quickly recap the last class what I had taught and then I'll start today's class. So basically we were talking about regression, right? So what is regression and what is the practical significance of the linear regression? We were talking about that. So basically in regression, we told that we have a set of data points which is obtained from experiments, and that data points we plot in the XY plane, and then we try to find a curve which is very close to all the data points. So that is what is called regression, right? So in that we gave an example of an experiment where we are recording the velocity of a car at different instants of time. And these were the velocity and time data. And from that we plotted on the XY curve or the VT graph. We plotted the velocities with the corresponding time intervals. And in that we saw that there are these red points here in this graph. It denotes the different data points. And then we concluded that there can be only one line which is very close, in which the error will be the minimum. So that line or that straight line is called the line of best fit. So that was the main crux or the main concept behind regression. And then we found out how we can find the equation of the best fit line. From that is just different types of formulas are there for linear regression. Basically, we found out how to find the slope of that line and what is to be minimized. So the error is to be minimized, right? So how to calculate the error at each step, that is at for each data value, how to calculate the errors and all that we looked into. So that was all about regression. So now today we will look into a new topic which is called as interpolation. So first we need to understand what is interpolation and what is the difference between regression and interpolation. So we will side by side, we'll look into both the concepts and we'll try to understand what is the difference between regression and interpolation. Okay. So this side we are talking about regression versus interpolation. So regression is nothing but a curve fitting technique. So it is nothing but curve fitting technique. That is, here suppose you have a set of data points like this. This is X, this is Y. And as a result of experiments, suppose you have obtained some data points which are like this. You have a data points like this. Okay. So now how to find that regression line? So it is the best fit line, right? So suppose you have a line like this. Suppose this is the best fit line. That is, the points on this line, it best mimics the data. So this is nothing but a curve that best mimics the obtained experimental data. However, in interpolation, what happens? So here there is no condition that the best fit line should pass through all the data points. There is no such condition like that. We have to find the line which best represents the data. A straight line which best represents the data. So that is known as linear regression. However, in interpolation, what we do is we draw a curve which traces all the data points. Or find a function that is a functional form that traces all the data points. So suppose I'll show the same example here. Suppose you have obtained some data points like this. Suppose you have obtained some data points like this. Okay. So now in interpolation, what we do, we basically join all these points by a curve. It need not be a straight line. So suppose this is the curve which joins all these data points. So this is known as the equation of this curve is known as the interpolating polynomial. So the main difference between this curve fit, this regression and interpolation is that the regression polynomial, that is the regression line of best fit line of regression, that need not pass through all the data points. However, in interpolation, the plot of the interpolating polynomial, it basically passes through all the data points. So can you tell me, both are like a sort of what to say, a sort of approximation to the data points which we have. So can you tell me which one, this regression or interpolation, based on seeing these curves, which one is more accurate representation of the data? The interpolating polynomial or the line of regression? Which one do you think is more accurate?
Regression one.
Why?
Because what can I say? It minimizes the distance between various points.
Yes, but what about in interpolation? Interpolating polynomial, what it is doing?
In interpolating interpolation, just suppose the points are very, very far, so it will pass through every points. So it will look very complicated. So that's why it's not good.
No, you're not getting the correct thing, because see here actually your curve is passing through all the points, right? So what do you mean by accuracy? That your predicted value and your obtained value should be as close as possible, right? So if your curve is passing through all the data points, so it indirectly means that your expected value and your obtained value both are same. So that is more accurate, right? Rather than we are having some error here. In the regression thing, we are having at every point we are having some error. However, in this interpolation thing, we are not having any error, because we are determining a polynomial which exactly passes through all these points. So that's why this interpolation is more accurate. Is it clear?
It is clear, but I wanted to ask that if just suppose the points are scattered all over the 2D plane, so it will just circle, I think. That situation also happen.
Yes, I'll show you. That suppose you are telling that there are scattered points, right?
Yes, all over the 2D plane.
And suppose you have like this, you have a lot of points. Correct, like this you are telling, right?
Yeah, you
then
can
you
say.
have to yes.
Means more up and downs also, not just a line. Okay. Also more points. Okay. Randomly points all over the plane.
Okay. You have to join all the points by a polynomial. That's what by. So like this, suppose if you have.
Yes. You're
getting. Like this you are telling, right? So that, yes, that is complicated. That is complicated. Getting an interpolating polynomial that requires more complication than more computational effort than the regression. That is correct. But if you see the accuracy thing in interpolation, it is more because your polynomial, it passes through all these points. That is complicated and that is difficult to get, right? But it should pass through all the points like this. The shape might look awkward, everything is okay. Once I start this interpolation, how to find the equation of the interpolating polynomial, you will see. I can also show you that the expected value and the obtained value, those are exactly accurate, means exactly same in interpolation. Because it is passing through all the points. Since it is passing through all the points, at that point, suppose I will show you in the same graph, I'll draw both the interpolating thing and the this thing. Is there, right? So this red curve, it shows the interpolating polynomial. And if I do the line of regression, suppose I do the line of regression, it will be something like this, right? This green line is representing the line of regression. So now you see here, suppose at this value of x, 1 second. This is the value of x, say x1. So at this point, if I see your obtained value and the expected value using the obtained value, that is the experimental value, and the obtained value using interpolation is the blue dot. That is the same because it lies on the interpolating polynomial. However, for the regression line, if I see the the obtained value, it is somewhere down, right, on the green line. So there is an error for the regression thing. However, for the interpolating polynomial, okay, and here also you see, suppose, so this value of x, suppose x3 I am telling. So at x3, if you forget the regression line first, just see the interpolating curve. Your blue dot which I have marked here, that is the experimental data obtained as well as the value of x for that value of y for that particular x using the interpolating polynomial. So both are same. So the error is not there. The error is 0. However, if you consider the line of regression, here your obtained value is this one. However, your experimental value was this blue dot only. So there is an error. This much error is there, right? This is the error. So that's what the difference is. Did you understand? Is it clear?
Yes, I got it.
Archana, is it clear?
Yes, sir.
Okay. Okay, so I'll move forward. So there is one more concept known as extrapolation, right? I'll just try to explain the difference between interpolation and what is the difference between interpolation and extrapolation. Okay, interpolation I have just now described. So basically, you have a set of data points. This is x. Suppose you have a set of data points like this. So what you do in interpolation is that you join all this by a curve, right? So this is your interpolating polynomial or the graph of the interpolating polynomial. So suppose there was, I'll mark the points once again. This is one data point. This is another data point. The origin also it is there. Okay. So what is the domain of this function? That is the value of x here. So suppose this is x1 and here it is x5, x1, x2, x3, x4. Okay, so your this one x should always belong. Suppose the equation of this interpolating polynomial you have obtained as it is some 1, 2, 3, 4 points, right? So you'll get a cubic equation. Don't worry about this. I'll explain it. Suppose you have got a polynomial this. So if you want to find the value of this curve at any random point, suppose the point is somewhere here, some xk I am telling. So basically this xk you can substitute in this y and you can find the value of the y at that particular x. So in interpolation, this x, the value at which you are finding, so that should be within the range of the data points. That is, your random xk should always be within the range of x1 and x5. So that is the limitation of interpolation. So interpolating a curve, interpolating a set of data points, that basically means you can find the value of that function at any random point within the range of that. So any point, suppose you want to find the value of the curve and extend it to say some other point which is beyond this range. Suppose here you find xn. So you want this value. So this is not possible in interpolation. You cannot extend the curve beyond your range of data points. It is only valid, this y equal to this one is only valid for x belongs to x1 to x5. Not less than x1, neither greater than x5. However, in extrapolation, what happens is in extrapolation, actually, suppose you have this many data points. Suppose you have a data points like this, right? So you have got a polynomial like this. Suppose one more data point is there. These are the data points. So you can extend this graph in either direction. Suppose this is x1 and this is x2, x3, x6, right? So you can find this x here, this xk, that is the random value of x at which you want to find the value of y, that can be between minus infinity to infinity. There is no range. You can just extend this curve. Suppose this is 0, this is 10. Your data points are within 0 to 10. However, you want to find the value of the function at some other point. Suppose say 20. So basically you can substitute in this polynomial y equal to this one. You can just substitute xk equal to 20 or x equal to 20 and find the value of y. So that is extrapolation. However, in interpolation, I'm once again repeating the concept. Your x value should be within the range of the data points. That is, it should be within the range of the minimum and maximum value of x. It cannot be beyond that range. So that is interpolation, whereas extrapolation is based on a set of data. You want to predict the value of x at some other point which is beyond the range. Right. Suppose you have say you have done the some experiments in chemistry. Suppose you are doing some experiments and over time you are monitoring the value of some concentration of some liquid or over not time some other variable you are taking as the independent variable and you want the value of the you have done the experiment for say 100 minutes. I'm just telling randomly for 100 minutes you have 100 datas, the value of the concentration of the solution at say t equal to 1, t equal to 2, like that. For t till t equal to 100 you have a set of 100 datas. So what you don't do it for say 5 hours, 6 hours. What you do, we do it for 100 minutes and based on that data we try to find a polynomial which passes through all these points, and then for a value of say x equal to 500, which you have not done the experiment, you don't have the actual data for that, but you can always extrapolate the from the obtained data, you can extrapolate that and you can find what can be the value of that function at an unknown point x, which is beyond the range. Is it clear? Is the concept clear?
Yes, it is.
Okay. Archana, is it clear?
Yes, sir.
You understood the difference between interpolation and extrapolation, right?
Yes, sir.
So now in this course, we will be looking only into interpolation. We will not be looking into extrapolation. So we'll see the different interpolation techniques. So interpolation is nothing but is fitting a curve or fitting a polynomial of degree So suppose you have done your experiment, any experiment you have done, and you have obtained 4 sets of values of x and y. Suppose at 4 time intervals you have performed your experiment and you have obtained 4 set of data points. So you have for say t equal to 1, you have a value of y. You have for t equal to 2, you have another value. T equal to 3, t equal to 4, you have 4 different values. So just remember this point. We will see why it is happening. If you have n data points, you can fit a polynomial of degree n minus 1. Suppose you have 4 data points. To represent those 4 data points by a polynomial, most accurate will be 3 degree polynomial. If you have 5 data points, you can fit a 4 degree polynomial to that. So just remember this. If you have n plus 1 data points, you can fit a polynomial of degree n. So why this is happening, we will see into it later on. So here, unlike regression, there are no degrees of freedom. So what do you mean by degrees of freedom? Basically, if you look into this curve, so here, these are the data points, right? In regression, there can be multiple lines. This is one blue line I have drawn. Another line can be like this. Another line can be like this, right? The accuracy will be minimum for only one line, but there can be multiple lines which best represents that data. However, in regression, we have no degrees of freedom because in interpolation. So in interpolation, what happens? The curve should pass through all the data points, and that will be only one curve is possible. That is an only one and unique curve is possible, which passes through all these data points. So basically in interpolation, we have no degrees of freedom. That is, we get a unique polynomial. Is it clear?
Yes, yes, it is clear.
The polynomial passes through all the data points, right? So first, am I going too fast or is the pace okay for you?
It is okay, okay.
Okay. So first we will look into Newton's interpolation formula. So in Newton's interpolation formula, so there is one condition to be satisfied when we can use Newton's interpolation formula. So here your values of y should be known at equispaced values of x. So what does this mean? I'll show you by an example. Suppose this is x and this is y. You have performed experiments. Suppose you have 4 data points, right? Suppose x is 1, 2, 3, 4, and for that y you have 10, 30, 40, 50. So here the difference between the consecutive values of x, it is 1, right? From 1 we are getting to 2, 2 to 3, 3 to 4. So in this type of problems, Newton's interpolation formula can be used. However, suppose I have the value of y at x equal to 1.5, then again at 2, then again at 3.5, then again at 4.5. Here, the difference between the consecutive values of x is not the same. First it is 0.5, then it is 1, then it is 1. So here we cannot use Newton's difference interpolation formula. Only for equispaced values of x it is applicable. So this is one of the conditions of this Newton's interpolation formula. So now we will look into what is called as forward difference. So we represent forward difference by delta yi. It is equal to the value of y, that is yi plus 1 minus yi. Similarly, delta xi will be equal to xi plus 1 xi. So we will see. So these are the values of y, right? Suppose this is y naught, this is y1, this is y2, this is y3. So what will be delta? Suppose I'm just giving the example. What will be delta y1? Can you tell me, Archana, what is delta y1 here? Or sorry, delta y0, you tell me first. Can any one of you tell what is delta y0 here?
It will be 30 minus 10, 20.
Yes. Delta y1. Archana, can you tell me what is delta y1?
Sir, that is 40 minus 30. 10.
Yes. So like this delta y2.
10. 50 minus 40.
Yes, correct. So like this, we find the difference. This is called the forward difference because we are moving in the forward direction. For delta y0, we are looking at y1 minus y0. Similarly, for delta y1, we are looking at y2 minus y1, like that. So this is the first order difference. Okay. So now if I want to find out higher order differences, how will I do? Suppose you want to find out delta. So this is not delta square. This is basically delta yi. The order is 2. There is a second order difference. So how will you do it? So this basically means delta of delta yi, which further simplifies to what is delta yi? Yi plus 1 minus yi. So you can just substitute here delta if I bring out. What is delta I plus 1? Nasim, can you tell me? Just looking at delta yi, can you tell me what is delta yi plus 1?
I couldn't get it.
Delta yi you understood, right? It is yi plus 1 minus yi.
Yeah.
So similarly, how can you find out delta yi plus 1?
Okay. So it will be yi2, no, yi plus 2 minus yi plus 1.
Yes, correct. So this is delta yi plus 1 and delta yi we know yi plus 1 minus yi. So it is basically delta square, rather delta yi of the order 2. So this is the second order divided difference of y. So like this, if we just do like this, and if we try to generalize, that is jth order difference of yi, it will be delta yi plus 1 minus delta j minus 1 yi. So this is the general formula. This is, you don't need to remember, you can just compute every step. So this is the general formula for the jth order difference of for jth order forward difference of y. All right. So one thing we will do here, do some variable transformation. Okay. Suppose I'm defining a parameter which is known as alpha here. Just for the ease of calculation, I'm doing that. So you will understand when I solve the problems, how is it going to help me. So suppose I define this x minus x naught by delta x as alpha. What is x naught? X naught is the first value of x in the given data, and x is the any value of x, random value of x at which you want to find the value of y. So x minus x naught by delta x. So that's what we just defined this function, right? So now this interpolating polynomial, what is the form of that interpolating polynomial? It was basically like this. Okay. So now we just reframe this equation as, just in place of x, we write it as x minus x naught. And accordingly, we have to, it will not remain a naught, it will be rather a naught dash. A3 x minus x naught. Okay. So now in this, suppose this is the actual polynomial was a naught plus a1x plus a2x square plus a3x cubed plus up to an xn x to the power n. However, we just reframe this polynomial and it is the only the coefficients will change. So we can write it as a naught plus a1 into x minus x naught, a2 into x minus x naught whole square plus a3 into x minus x naught whole cubed, and this will continue till an x minus x naught whole power n. Is it clear? One second, I did one mistake here. Basically, not square, rather this one. So this is basically the polynomial representation. So now you can ask that how you can tell me that this polynomial will pass through all the points x naught, y naught, x1, y1, x2, y2, x3, y3, x and y. So suppose I want to find the value of this polynomial at x equal to x naught. So if I substitute x equal to x naught here, what will be my, this one is y naught, right? The value of y. And this one will be a naught. And all the remaining terms, you have x minus x naught there. So all will reduce to 0. So your y naught here is a naught. So y naught is equal to a naught here. Similarly, at x equal to x1, your y is equal to y1, right? So we substitute this one, y1 equal to a naught plus a1, x is x1, and all other terms will go to 0. So from this, if we try to find out what is a1, basically y1 minus a naught is again y naught, right? Y1 minus y. So we have found out an expression for a naught here. Similarly, if I substitute at x equal to x2, y equal to y2. Are the things clear? Are you able to follow, right, the derivation?
Can you repeat the previous step once again?
Yes. So this is my polynomial. I'll erase this one, otherwise it will create confusion. So just remember, this is my polynomial. What you have a set of data points x naught, y naught, x1, y1, x2, y2, like that. N data points you have till xn, yn. Okay. So from that, you are trying to find a polynomial, which equation of the polynomial which passes through all these data points. So you represent those that equation of the polynomial like this. Some a naught plus a1 x minus x naught, a2 x minus x naught into x minus x1, like that we represent. So now I am to find the equation of this polynomial. What is the unknown thing? This x naught, x1 are all known to me. Only these coefficients, right? A naught, a1, a2, a. I need to find out these coefficients. So from the known values of x and y, we have to find out these coefficients. So we know at x equal to x naught, your y is equal to y naught. So in this equation, we substitute x equal to x naught and y equal to y naught. So y means the right hand side. Rather, I'll write it as y. So y is equal to y naught. That is LHS is y naught, and the first term is a naught, and all other terms have reduced to 0 if we substitute x equal to x naught. So we get y naught equals to a naught. Similarly, if we substitute in this equation x equal to x1 and y equal to y1, so y1 will be equal to a naught plus only second term will remain. From that we can find out a1. So like this, if I substitute x equal to x2, y is y2, right? y2 is equal to basically a naught. Now is it clear, Nasim?
Yes, I understood.
So remaining all terms will reduce to 0. So now if I substitute, I just simplify this one, y2 will be a naught is y naught, a1 is, one second. So this is basically we can write delta y naught by delta x. So a1 we represent by delta y naught by delta x. 2 minus x naught, a2 into, what is x2 minus x naught? We have x naught, x1, x2, right? So this difference is delta x. This difference is delta x. So x2 minus x naught is 2 delta x. Again, x2 minus x1 is delta x. So y2 equals to y naught plus. Now we will substitute delta y naught. We will substitute y1 minus y naught by x1 minus x naught. Again, one second now. So okay, delta x will remain. Delta x, if I keep x2 minus x naught is 2 delta x, right? A2, 2a2 delta x square. So y2 equal to y naught plus delta x will cancel, 2y1 minus y naught, 2a2 delta x square. So from this we have to find out a2, right? y2 minus y naught minus 2y1 minus y naught. This one divided by 2 delta x square. So just if I replace a2 is y2 minus, what is there? Y naught minus this one. Y naught minus 2y1 plus 2y naught by 2 delta x. So it is y2 minus 2y1 plus y naught. So what is this upper term? y2 minus 2y1 plus y naught. We just now defined it, right? So here it was. Delta square yi is yi plus 2 minus 2yi plus 1 plus yi. So here if you substitute delta y as 0, if you substitute I as 0, it is basically y2 minus 2y1 plus y naught. Just in place of in this equation delta square yi, if I substitute I equal to 0, we will get y2 minus 2y1 plus y naught. So here basically we have got that term. So it is delta square y naught. So you have obtained a2 as delta square y naught. This is a2. Similarly, a1, how much we have obtained? A1 is delta y naught by delta x. and A naught is basically Y naught. So now based on this, I want A naught, A1, A2 I have obtained. Similarly, if it is an nth degree polynomial, we have like this n coefficients, right? An we have to find out. So from this we can generalize this. This is the general formula for An. It is basically the nth order difference of y naught divided by n factorial multiplied by delta x power n. Is the concept clear? The derivation you can just, I'll open this page once again. You can go through it once again and do it yourself. Otherwise, just by seeing, you will not understand. Any doubts, any confusions, you can tell me. I'll take a pause here. Any doubts, Nasim or Archana?
No, sir. Sir, can you solve on problem basis on this formulas?
Yes, yes, I'll solve. Just I have to first describe the theory
Yes, sir.
behind this. I'll solve
Yes,
it.
yes.
I wanted to ask that this Newton's method, it's for equispaced points. If the points are not equispaced, then we have to use that curve regression.
No, no, no. Interpolation and regression are two different concepts. If you are asked to find an interpolating polynomial, you cannot use regression for that.
Okay, okay.
Regression doesn't come into picture. Just for the sake of just last class, since we had described this regression, I wanted to explain what is the basic difference. Equispaced and all, there are different interpolation techniques for non-equispaced this x values also. Lagrange's interpolating polynomial is there. So that is beyond your scope here. Or you have Hermite's interpolating polynomial. Lot of things are there.
Okay, okay, okay. Understood, understood.
Regression is not an alternative to your interpolation. Both are totally different concepts. Okay. I'll just take a 5 minutes pause and then I'll start again. Okay.
Okay.
Okay, so I'll start. You're here, right?
Yes, you can continue.
Okay. Okay, so yes. So now we will move to, so we have found out the coefficients, right? A1, A0, A1, A2, AN, like that. So now we will see, now we'll reconstruct the polynomial. So what was my polynomial? It was A0, A1 x minus x naught plus A2 x minus x naught x minus x1. That will an x minus x naught into x minus x1 dot x minus xn. So like this, if we now substitute the values of a naught, a1 and a2, all those values, so it will be basically y naught plus delta y naught by delta x, that is a1 x minus x naught. A2 is delta square y naught by 2 delta, sorry, 2 delta x square into x minus x naught, x minus x1 dot plus del power n y naught del x power n x minus x naught x minus x1 dot x minus x. So this is the final interpolating polynomial in terms of x. So now, as I told you previously, that we want to do a variable transformation. That is, we want to represent not in terms of x, rather in terms of alpha for the ease of calculation. So we will see what was alpha. Alpha was x minus x naught by delta x, right? So here, if in place of x minus x naught by delta x, we will represent alpha. So one more term we have here, that is x minus x1 by delta x, right? So here, let alpha equal to x minus x naught by delta x. So therefore, what will be my x minus x1 by delta x in terms of alpha if we want to write? What is x1? X naught plus delta x by delta. So it is basically x minus x naught by delta x minus 1, which is nothing but alpha minus 1. So similarly, this x minus, if I want to generalize this, it is basically alpha minus k. So keeping this in mind, we will see how we can replace this. So it was y naught plus, what is the first term? First term is delta y naught by delta x into x minus x naught. So directly x minus x naught by delta x will represent by alpha. So it will be alpha delta y naught. Next you have x minus x naught by delta x. Here square is there. So what we do is we divide this delta x here and delta x here. So basically x minus x naught by delta x is alpha and x minus x1 by delta x is alpha minus 1, right? So you have alpha minus 1, alpha minus 2, next one is alpha minus 1 by 2 into del square y naught. So like this, if you go on substituting, last term will be alpha minus 1, alpha minus 2 dot alpha minus n minus 1 by n factorial multiplied by del power n y naught. So this is the formula in terms of not x, rather alpha. So this is the value formula for the interpolating polynomial in terms of alpha. So you might ask a question, why we are representing in terms of alpha? Why not in terms of x? So you will see that is nothing but just reframing that formula. So that is basically because for the ease of calculation. So this alpha is not dependent on your alpha is dependent on your x and y. However, this polynomial, it is a general expression, right? So it will not depend on values of x and values of y. So first you can calculate alpha based on your values of x and y, and then you no need there is no more a need to calculate. At every step, you don't need to use that values of x and y. So that's for for the ease of the problem, we are just representing that by alpha. So now we will see one problem based on this Newton's interpolation formula. Is it clear? The concept is clear, right?
Yes, it is clear.
Okay. So the question here is, there are multiple values of x and y given. So x is 1, 2, 3, 4. And the values of yi are 17. Sorry. First value is 7, 17, 53, 157. So it is told, find a third degree polynomial, because 4 data points are there. So polynomial, you will get a third degree polynomial, right? So find a third degree polynomial for the given data. Okay, so first we'll prepare a table xi and yi, right? 1, 2, 3, 4, 7, 17, 53, 1. First I will see delta yi. So what is delta yi? First one will be including these values. So delta y0 will be 17 minus 7 is 10. Delta y1 is 53 minus 17 is 36. And delta y2 is 104. So second order difference using these two. So it is del square y0. What is that? 26. Del square y1 is 68. Third order difference, del cube, this is 42. So you have prepared this table. Now there is nothing else, just you have to substitute. So what is P3 of alpha? It is basically y0 plus alpha delta y0 alpha into alpha minus 1 del square y0 by 2. So you have till third degree, right? So you have 4 terms, alpha minus 1, alpha minus 2, del cube y0 by 3 factorial. Correct? So now let it remain in terms of alpha. Alpha will substitute at last. So delta y0 is 10, right? So y0 plus 10, y0 also will substitute. What is y0? Can someone tell me?
7.
7 plus 10 alpha plus alpha into alpha minus 1. Del square y0 is 26, right? 26 by 2. Alpha minus 1. 42 by 3 factorial 6. 7 plus 10 alpha. 13 alpha minus 1. Alpha minus 1, alpha minus 2 into 7. 7. Yeah, just simplifying this. Plus. So this is basically 7 into alpha plus 2 plus 10 alpha. Therefore, 7 alpha cube plus 13 alpha square minus alpha square. Second. Just a second, some calculation I've done mistake, I think. Second. Here I've done some mistake. It is alpha square minus 2 minus 3 alpha. This will be 3 alpha square. So this will be, so it is 7 alpha cube minus 8 alpha square. And then you have 10 minus 13 minus 3 alpha. No, 8 alpha is there, right? 1 second. So this is 14 alpha plus 24 minus plus 11 alpha plus 7. So this is your interpolating polynomial in terms of alpha. So now at the last step, we will now substitute alpha because your polynomial answer final should be in terms of x. What is alpha? X minus x naught by delta x. So your x naught was 1 and delta x is also 1. So alpha is x minus 1. Therefore, P3 of x will be, it was 7x minus 1 whole cube minus 8 alpha square plus 11 alpha. So if you substitute, 7x cube minus 1 minus 3x square plus 3x. X square plus 16x. So if you simplify this, you will get 7x cube, 29x square. So this is your final answer. So this is your final answer. That is the interpolating polynomial which fits all the 4 data. Is the concept clear to you? Or should I go through it once again?
Yes, the concept is clear.
Archana, is it clear?
Yes, sir.
Okay. So now what we'll do is we'll see another approach of finding this polynomial. Okay. So that is a bit complicated approach, but we'll look into it once. Just means it isn't that approach is not used generally. So that is known as the matrix approach. Okay. So what we do in the matrix approach. So suppose you have a set of data points, right? X naught, x1. Suppose you have this one, x naught, y naught, x1, y1, x2, y2, like this up to some n data points you are having. Xn, yn. Okay. So now, suppose I represent this by a polynomial of nth degree, right? So it is basically, this is the general formula. So now how do I represent, how do I get a matrix thing? So what is y naught here? It is a naught, a1 x naught, a2 x naught square plus like this n xn. Similarly, y1, if I just substitute the values of x, a1 x1, a2 x1 squared, an x1 power. Similarly, y2, a0 square plus dot 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 x2 to the power. Like this, if I substitute all the values of x in y, we will get this set of linear equations, right? Okay. So now if I represent this by this set of equations by a matrix thing, how it will look like. So this will look like y1, y2 like this up to yn. So this will be basically 1 x0 square x0 power n. Again 1 x1 square dot x1 power n. 1 xn square xn power n multiplied by this is the now this is the coefficient matrix a0 a1 like this you have a. So we can write y is equal to this is the x matrix I am saying multiplied by a. So from this we need to find out a. What is a? A is x inverse. So like this also you can find out the coefficient matrix that is a0 a1 up to an. However, this is more computationally expensive because you need to find this a matrix first, x matrix first, and then you have to take the inverse. Suppose you have 4 data points, you will have five, you will have if you have 4 data points, you will have 5 x 5 matrix. If you have 3 data points, you will have 4 x 4 matrix. So getting the inverse of that matrix is very difficult. So generally we don't use this process, but just for example, I wanted to explain how to get it. What is the other way of getting this matrix, this coefficients rather. Is it clear to you? Any questions?
Yeah, it's clear. No questions.
No, sir.
Okay. So we'll just try to solve the same problem. One second. Same problem, the previous one. We'll try to solve by this approach. Okay. I'll just do it. What is basically x you have, y, right? So what were the values? 5, 10, 15, 20, 10, 55. Okay. So here you don't need to find all those y differences. That is later. So first, what is x1? Then x0. x0 square and x0 cube. Then you have another one, x1, that is 10, 100, 1000. 1, 15, 15 cube is 3575. Then you have the fourth column, which is 1, 20, 400, and 8000. This is my x. So there first you have to calculate the inverse of x. Either you can calculate inverse using the Gaussian elimination or using the adjoint matrix, whatever is possible for you. So I'm not doing the inverse calculation here. I'll just write is minus 4, minus 6, 4, minus 1. Then you have minus 13 by 15, minus 7 by 5, minus 11 by 30. 3 by 5 minus 4 by 25, 7 by 50, This is X inverse, right? So now you have to find out A. What is A? That is the coefficient matrix which is X inverse Y. So Y, you know, this is this 10, 55, 92, 120, right? Y matrix is basically. So if you multiply this Y with X inverse with this Y, you will get A as minus 42, 11.03 minus 0. So this is it. So for this, A0, A1, A2, A3. A0 is minus 42, A1 is 11.03, A2 is minus 0.12, and A3 is minus 0.00133. So these are the coefficients, and just you can substitute in the polynomial A0 plus A1x plus A2x square plus A3x cube will get the total polynomial. So this is just another way. However, this is more computationally expensive because of calculating the inverse. Computationally it is very expensive. Okay. So now up till this everything is clear.
Yes, yes, it is clear.
Any questions with the assignments? Anything? Yes, Archana, are you telling anything?
Sir, yes, sir. We how to find the values of A0, A1, A2, A3.
Were you listening to the class? What I was telling you today?
No, sir. By not by matrix method, sir.
Then what I
The
discussed in today's class, can you tell me once?
interpolation polynomial, sir.
What polynomial?
Nihal,
You are not audible properly. Can you tell one? Can you come back once again?
sir, like interpolation uh, polynomial using polynomial fitting. Interpolation using polynomial.
So what I was okay. You tell me what I discussed in today's class. Do you remember? First, what I started with. Did I start with the matrix approach first, or something else I told?
Yeah, something else, sir.
What was that?
That is the how to find the third degree polynomial for the given data.
Was that using matrix approach or something else?
Something else, sir. Newton's method.
Then
Newton's
are you talking of that or something else you are telling?
This question I didn't get, sir, in the week 7 assignment.
Week 7. Can you
Yeah.
send the screenshot of that?
Okay, sir.
Please send the screenshot of that question. I will see it.
Yes, sir. Sir, I have sent, sir.
Yes, I'm seeing. Hmm. So yes. So what you want? What is this? What is asking? It's asking the values of A0, A1, A2, and A3, right? So I solved a similar problem just before this matrix approach. What I did here, this one only, this problem. Did you understand? Did you listen to it or You didn't listen.
No, sir, I am listening.
Then I have described the same problem, just the values are different. I've calculated
Yeah,
this
yeah, yes.
this polynomial I've calculated, right? So now
Yeah,
can you tell me from this polynomial what is a0, a1 and a2?
sir, A naught is 7.
Is a0 7? You look at the equation which is given. Y is equal to a0 plus a1x plus a2x square plus a3x cube. What is a0? What is a0?
Sir, A naught is A1x plus A2x.
What you look at the screen, you can see I have written a0 plus a1x plus a2x square plus a3x cube. If you compare
Yes.
these two equations, what are the values of a0, a1, a2, and a3?
Sir, A naught is minus 19.
A1,
A1 is 48.
A2 is
A2 is minus 29. A3 is
hmm.
7.
So is it clear now
Yeah,
how to
yes, sir.
solve this?
Yes, sir.
Okay. Any other doubts you have
No,
on the
sir. No,
questions?
no, sir. No, sir.
Okay. Okay. One more technique is remaining. I'll discuss that. Okay, so we'll look into now the Lagrange's interpolating polynomial. So this was Newton's interpolating polynomial. Then we looked into how to solve it analytically and then using the matrix approach, right? So now we will be looking into so Lagrange's interpolating polynomial is nothing but another representation of the same thing. You have a set of data and you need to represent that as a polynomial. So there we represented here in Newton's interpolation, we basically represented as a general form, a naught plus a1x, a2x square like that. Rather here we will represent it in a more reformed or a convenient way. We will try to represent it using Lagrange's interpolating polynomial. So what is it? So first, I'll write the formula for that. So this is the formula for the Lagrange's interpolating polynomial. So Li of x is basically your Lagrange's interpolating polynomial. What is Li of x? So it is basically, this is the symbol for product. Like we use for summation, this upper one, we use the pi symbol for product, right? I'll first write it down and then I'll explain. This is the formula for the Lagrange's interpolating polynomial. And then suppose we have, suppose now if I expand this, what we will get? The first equation, if I expand for I equal to 1, it is L1 of x, y of x1 plus L2 of x into y of x2 dot dot dot. So this is this one. So can you tell me what is L1 of x from the above formula? Anyone? What is L1 of x in place of Li of x in the above equation? If I represent I equal to 1, what does it reduce to? Can anyone tell? Okay, I will write the, yes, tell me.
X minus x1 upon here means j not equal to I. So how to do that? I cannot
Yes.
get.
Okay, first one I'll write you. See, so it is basically, so for L1 of x, what is the value of I? I is 1, right? So your j cannot be
Yes.
equal to 1. So j will start from 2. So it is basically first term is x minus x2, I is 1, j is 2. Next term is x minus x3 by x1 minus x3. Like this, it will go on till the value of I n, x minus xn. Is this clear? How I am getting L1 of x?
Yes, yes, it is clear.
Now, can you tell me what is L2 of x, Archana? Are you there? Okay, maybe she is not there. Nasim, can you tell me what will be L2 of x?
It will be x minus x3 upon x2 minus x3
Why?
multiplied.
Why j equal to 1 is not included? Because I is 2 here, right? So j cannot be
Size,
equal to 2.
it will be equal to 3.
It can be equal to anything other than 2. It can be 1, 3 up to n.
Okay, okay.
Okay. So
Okay.
this will be, only this 2 will be missing here. X minus x1 by x2 minus x1, x minus x3, x2 minus x3, dot dot dot, x minus xn, x2 minus x. Is it clear?
Yes, got it.
So tell me what is L3 of x?
It will be x minus x3
Again, you are doing the same mistake. I told j cannot be equal to I. No, I is 3 here.
I is 3. So x minus x1 upon it is x3 minus x1.
Next term.
It will be x minus
x2, right?
x2, yes.
x3
x3
minus
minus.
x. So 2 cannot be there.
Okay.
Sorry, 3 cannot be there. Then x minus x4 by x3 minus x4. Like this, it will continue. Clear? I hope it is clear to you.
Yes, it is clear.
Okay, so the Lagrange's polynomials are there. Now we will substitute this L1, all these things. All this L1, L2, L3 you have. So basically, this will be, I'm not writing it again, L1 of x into y of x1, L2 of x, y of x2, like this. Ln of x. So this is the final interpolating polynomial in y in terms of x. Clear, right?
Yes, clear.
Okay. Archana, is it clear? Okay, I'll move forward. So the same problem I will try to solve using Lagrange's polynomial. Okay. So you have your x and y. 5, 10, 15, and 20. And you have 10 on 20. So here it is told, find the interpolating polynomial. Lagrange's interpolating polynomial to calculate y at x equal to 7. At x equal to 7, you have to find out what is the value of y. Okay, so for that, first you need to find out the polynomial. Then you substitute in place of x 7 and then find out y. Okay, so the first step here will be to find out L1. L1 of, so x is given here. So, okay, first I'll write in terms of L1 of x. What will be L1 of x? I is 1, right? So 1 will be missing. X minus x2, x minus x3, like this up to x minus, okay. 3, x4, by x1 minus x2, x1 minus x3, x1 minus x. So what is x here? X is given as 7, right? So at 7 you have to find out. 7 minus 10, 7 minus 15, 7 minus 20 by 5 minus 10, 5 minus 15, 5 minus 20. So this will come around 0.416. Similarly, find out L2 of x. What is L2 of x? X minus x1 only. 3, 2 will be missing here, right? Minus x4. X1 minus x. Sorry, x2 minus x1. X2 minus x1, x2 minus x3 into x2 minus x. So if you substitute all the values, you will get L2 as 0.83. Similarly, you can find out L3 of x. What is L3 of x? You can just substitute this one, x minus x1. So this will come to minus 0.312. Similarly, if I calculate L4 of x, x minus x1, x minus x2, x minus x3 divided by x4 minus x1, x4 minus x2, x4 minus x3. This will come around 0.064. So you have L1, L2, L3, L4. So now you have to find the polynomial, right? What is it? L1 into y1, L2 into y2, L3 into y3, L4 into y. So at y at 7 will be L1. If you substitute y1, y2, y3, you know 10, 55, 92 and 120, right? So if you substitute this, you will get a value around 28.396. So I'll just substitute 10 plus, after 10 what we have, 55 into 0.832, 92 into minus 0.312, 120 into 0.064. So this will give me 28.396. So this is the value of y at x equal to 7. Is it clear to you?
Yes, it is clear.
Okay. Archana, is it clear?
Yes, sir.
So Lagrange's interpolating formula, how to find out L1, L2, L3 and L4. Then finally how to calculate the value of the interpolating polynomial. So I have described both these things.
Yes.
Okay. So next one is Newton's divided difference. So any problems are there on this Newton's divided difference in the assignment, or in the assignment anything is there on this?
Yes, sir. We have assignment 7. Newton divided difference.
Newton's divided difference is there, right?
Yes, sir.
Okay. So suppose you have the values of x and y here. You find out the first order difference, then the second order, and then you have the third order difference. x1, x2, x3, x4, right? So corresponding values of y are y1, y2, y3 and y4. So using these two, you can find out y21. Using these two, you can find out, just the representation is different here. y43. Using these two, you can find out 32, y of 321. Just a representation, nothing else. Y of 432. And using these two, you find out y of 432. So what are these? What is y of 2, 1? It is y2 minus y1 by x2 minus x1. Similarly, y of 3, 2. Similarly, you have y of 4, 3, right? y4 minus 3. So these are the first order differences. So now using these 2, 1 and 3, 2, we have y3, 2, 1. So it is nothing but y3, 2 minus y2, 1 by x3 minus x1. And using these two, we have y432, 43 minus y32 by x4 minus x2. These two second order differences, we have the third order difference. 4, 3, 2, 1. So it is nothing but y432 minus y321 by x4 minus x1. So now you have all these divided difference coefficients. These are called the coefficients of Newton's divided difference. Now using this, how to represent the polynomial? So it is basically y1 plus y21 into x minus x1 plus y321 x2 like this plus y4321 into x minus x1, x minus x2, x minus x. So this is nothing but the first Newton's interpolation formula that I described. It's same as that. Only the notation of the device, only the notation of the things are changing. Nothing else. And the way of representing the differences, there we had written delta y naught, delta square y naught like that. Just the way of representing, and some either like some change is there. And as a result, we are getting a different formula here. So I'll just quickly solve one problem. Just I'll not do the calculations. Same problem I will solve. 5, 10, 15, 20. Y is some 10, 55, 92. So can you tell me what is y21 here? Anyone?
Equal to, it will be 9.
Okay, you tell me this one. Y21 is
55
55 minus 10 by 10 minus 5, right? That is 9. Archana, can you tell me what is y32?
Yes, sir. Y32 is
No need to calculate. You tell me in terms of this minus this, like that. You tell me.
yes, sir. 92 minus 55 divided by
15.
15 minus 10.
So this will come around 7.4. Y4 comma 3. Can you tell me? 120 minus
120
92.
minus 92 divided by 20 minus
20 minus
15.
15.
Yes.
So it will come around 5.6. So these are the first orders. Now tell me the second order. 3, 2. What is y321?
7.4 minus 9
Divided by.
divided by.
Just remember this. When you do the second order, this divided by the denominator, just look
Yes,
at this
sir.
one. 2 and 1, right? So it is x2 minus x1.
Yeah,
Here
yeah.
it is 3, 2, 1. So it is x3 minus x1.
X3 minus x1.
Hmm.
15 minus
So
10.
So it is minus 1.6 by, is it? Oh, sorry, 15 minus 5, right? Is minus 0.16. Y432 is 5.6 minus 7.4 by x420 minus 10 is minus 0.18. And the third order 4321 minus 0.18 minus of minus 0.16 by 20 minus 5. So it is basically minus 0.02 by 50. So how much it will, so it will come some value, it will come, you can calculate that. So now if we want to find the polynomial, y is y1, that is 10 plus x minus x1, right? So it is x minus 5 into y21 plus x minus 5 into x minus 10 into y321 plus x minus 5, x minus 10, x minus 15 into minus 0.02. So you can calculate the value of y from here. Is this clear? Any doubts anywhere?
No, sir. No, sir. No, sir.
Any questions with the assignments?
I wanted to ask one question.
Yes, tell me.
I'm taking the example of Ohm's law. In
Hmm.
Ohm's law, the two variables are given, V and I.
Hmm.
So let us suppose like X is V voltage and Y is current.
Okay.
The values are given. So if we uh, follow this Newton's divided difference method, so the relationship, the polynomial we will get, it will give a means it will fit the curve.
Your voice is not audible, Nasim.
I am asking, let us suppose the X and Y
After
variable.
that, I heard it. You have the values of V and I, and you get a polynomial in terms of V and I, right?
Yes. So by following this Newton's divided difference, so the relationship we will get, it will interpolate between the values of X and Y.
Yes, correct. It's your voice is not coming.
Hello.
Yes. Tell me, you got an interpolating polynomial for V and I, then?
So means like in Ohm's law, the graph that is linear, but just suppose let us assume that the graph that is not linear. So the relationship we'll get between V and I, it will be that polynomial what we will get in after this Newton divided difference.
Yes,
So
what
do
you
you
are
understand it?
asking? No, your question, I am not able to hear anything.
Okay, let me do it on the paper. I'm sending. Just a minute.
Sir, can you please share the slide that finding the A0, A1, A2?
Yes, I'll share. I'll share this after the class. I'll share it.
Okay, I have sent that picture in the chat box.
I'll see it. Okay, so yes, you have like these points. Okay, first tell me, what you know. You know the relation between V and I is always linear, right? For an ideal situation.
Let us suppose that it is not linear, means they are means they are not connected. So after doing this Newton's dividend difference, so we will get the relationship in the form of a polynomial. I am asking. That is my question.
Yes, we will get a polynomial. So what is the thing here? I could not understand.
Means that is my question. The after doing this method, the relationship we will get, it will establish a relationship between V and I.
Yes. So if you
Okay,
don't
okay.
have the, if it is not linear, then obviously we'll get a relation between V and I, no?
Okay. This I wanted to assist.
Okay. Anything else? Any other confusions, doubts?
No confusion. Everything is clear.
Okay, Archana, everything is clear?
Yes, sir. Clear.
Okay, fine. Then we'll meet on Saturday. Next Saturday we'll meet, okay? The next class. Today I'm closing the session then. Bye.
Thank you, sir. Bye.
Hello.
Yes, Naseem, tell me.
So the next means the weekend class will be on next Saturday, not this week.
This Saturday, because this was the compensation class of the last Saturday, no? Second, so 14th you will have.
Okay, just after 4 days.
14th you will have the class.
Okay. Thank
Okay. Thank you.